don't know what's wrong with the music player. It seems to be like skipping a little bit, but hopefully it'll sort itself out. Let me adjust some stuff before we start. Okay, I guess we're ready. Let me do a stretch. This chair is really good for stretching, but it's just a simple little Amazon Basics chair, but it's really good. Oh, dang it! See, what happened to the music? Here's what we'll do. We'll load it in a different, what do you call it? A different player. Okay. No, that should stay playing, and then I can add one more. I don't remember what the title of that other game was. But I want to add one more thing to the playlist so that I don't have to worry about it later. So 1 second. Okay, let's do this. I can't find it. um, that's not it. I'm looking at other stuff on the other screen, so just a moment. Just a moment. Okay, almost there. We do this. We do... Well, let's just switch over to that when it's time. Okay, I think I've fiddled around enough. What's today? Today's Monday, right? Yeah, Monday. Um, I don't think anybody's here, but I'm doing good. Got off work. You know, going to work every day, not every day, but most of the time I start work at 4 o'clock. Um, and I've just gotten used to it. Sounds like a big deal. It's not really a big deal. Um, because you're used to that schedule. But it's nice to get off, you know, right around lunchtime, and then I just have the whole day to do whatever. Um, so today I got off at 10 o'clock because it's a 6 hour day, which is nice because, you know, 8 hour days, 9 hour days, those are just so long. At the end of the day, when you get home, or at the end of your shift or whatever, you just don't want to do anything. You're just tired. Um, Maybe not if you have a job where you sit around all day, like a desk job or something, but even then, that requires, you know, mental exertion and stuff. May not be as physical as, you know, a job at a grocery store, but could be even more like mentally consuming, I guess. Um, yeah, so today we are working on creating better starting soon and be right back scenes. So I'm gonna switch over to the scene just to show it off. But you'll see, like, this scene is really boring, and it's just some text that I threw up onto a well, let's do this. Yeah, okay, so you can hear me now, I think. But this is the starting soon screen, and it's pretty simple, and it works, but I think we can do something a little bit better than this. So that's the idea of today's stream, is um, what I want to do is use a browser source for those screens. So this screen here is just a text source. I don't know if anybody's ever used OBS. I'm not very fluent in OBS, but what you can do instead is you can add a browser source. So if I just do like this, did it not load? Oh. So it's cool. It just kind of goes to that website, and you know, this is the front page of Twitch right here. But what I want to do is host my own website, and then I can point this browser source URL to that website. So this will be a whole new project. Well, it's not going to be a very big project. It'll just be a single page. And my thought is that we'll just make a 3D scene on that page, and then, you know, let me draw it up. Go over here. Do that. Let me shift this over just a bit. So here's the page, and what I want to do is put some text in the page. So this will be like starting soon or be right back. But this is going to be on a URL, so, you know, this is some URL. But whatever this text is here, I want something that you can just pass it into the URL. So a really simple way to do that is to just do it as a search param, and then read that search param, you know, somewhere on the web page, and do something with it, you know, a script tag or whatever. And we can do that too. Because this will be something that maybe somebody else wants to use, and all they gotta do is just change the URL, and then there you go, it has the text. But what I'm thinking is we'll do like a search param, so search param has the question mark, and then the name of the param, so maybe like text, and then whatever text you want to put here. So in this case, it'd be like BRB. And that's it. That's like all that this website will do. And then what we can do is load it up in OBS and point it to this URL. I don't know, it'll probably just be the GitHub, like it'll be a static web page that is just thrown up on GitHub, and then the, I think it's like github.io or something. You know, like username and then github.io. Something like that. But we'll deploy it and we'll see where it's hosted and all that, and then maybe by the end of the stream we'll have it ready to go. So I do want to kind of show off like the inspiration that I want to, or like the look and feel that I kind of want to go for, and yeah, I still have it here. So what I'm thinking is something simple. Where's the first? Let me turn mute the audio for a second. Not mute it, but pause it. So let's jump ahead a little bit. I kind of want something like this. This Petscop like title screen. So it's just a text geometry, and then, you know, it's got probably um, post-processing effects to make it look old school. Uh, but this is kind of the look that I want to go for. And if you don't know what Petscop is, it's kind of like a analog horror um, video game. Dang it. Not in that screen, in this screen. Oh, it does that. I cannot copy and paste with the hotkeys. I have to like right click it and paste it. There. Yeah, so if you don't know Petscop, you can check it out. It's an interesting like analog horror. I'm not gonna like tell you all the details, but it's a YouTube series or whatever, and yeah, it's interesting. There's even I think there's even what's that guy's like Game Theory or something, that YouTube channel made a couple of videos on this. Um, so it's pretty old, 9 years old, but it's a classic. I don't know if it's a classic yet, but it's a good little series. But I kind of want to copy this look here, and I'm not talking about like the background, but at least this text geometry here and how it like wiggles. Um, so we'll do something similar. Yeah, like it goes like this or whatever. We can do that. That's pretty easy. Um, so that's inspiration number one. Inspiration number two. Put the music back on. Is let's see, what do I got? This Rakuga Kids game, but has like this almost like hand-drawn look to it. And this is the OST that's playing right now is from this game, but this is a game that we never got in the US. Let me see if I can get like a screenshot of the actual gameplay. But this is a cool little fighting game, but the characters are like toys or something that these kids up here. Can you guys see that? Yeah, you can kind of see that. But yeah, these like kids up here are fighting with these toys and stuff. It's like pretty cute little game, but it's an actual fighting game, and the characters or whatever, it's one of those like 2.5D games. So the characters are like flat planes with just different textures thrown on. So they're kind of like sprites, what we did last stream, but using an actual like sprite sheet and stuff. I guess I'm not sure, but so that's inspiration number two, and then Parappa the Rapper. That's kind of another one that I really like the look and style of. This is another one where the characters in the game are kind of like flat geometries, and then I don't know. It sounds like we need to do something with like flat geometry or something, and then I don't know, but we'll keep it simple for now. I might do we'll definitely want to do a second stream on this, but today's stream is just going to be like setting up the scene and stuff, and then we can, after everything is like put in place, we can then kind of like tweak the look and style of it. But I think most people know what Parappa the Rapper is, so that's another influence. And then Shin-Chan too has this kind of like hand-drawn style to it, which I really like. And I got a little scene from Shin-Chan, just a really little small clip from this anime. So I'm gonna play it, but hopefully it won't be too loud. We'll jump back a little bit. Oh, let's make it big.
A cool wet towel should feel better on your forehead than a warm poopy diaper.
You can tell like it's all like squiggly lines and I don't know if I can show this on Twitch. Yeah, but that like kind of like squiggly line art and stuff, also that's like one of those, is the kind of look that I'm gonna go for. But that'll probably happen either next stream. make a shader or something. I gotta do some research into how to uh, achieve that look. Because I'm thinking it can either be done with a post-processing effect or, um, in the materials somehow. We'll modify one of the materials, maybe like Toon Mesh or something, Toon Mesh material, and do that. Um, yeah, so this is kind of what we're gonna go for. It won't be exactly this, but it will be very similar. So let's get started. So this will be a new project, and I'm just gonna use Svelte because I know it and it's familiar. So to start a new Svelte project, you go like this, and I had to remind myself how to do this. So I got some, I use ZSH or something, and it has an autocomplete plugin, so it's really nice. I can just go. This is like in the history. I can just like, yep, that looks good. So I didn't know what to call this. I'm just gonna call it text geometry for now. Oh, audio's still too loud still. There we go. So let's go through this little thing, this little walkthrough. Minimal, TypeScript. I don't want any of these. Well, maybe Tailwind. I think I'll take Tailwind. Just so that styles are normalized. But this app will not have anything. It's just going to be a dumb little web page that has a scene in it. So that's all I want for these two. And then we'll take, I don't know, we'll take typography just in case. Maybe at the bottom of the page or something, we'll put a link to my GitHub or something like that. We'll use PNPM. Let's run it. Yeah, there we go. So there's our app. So far so good. And we go here, and this is what the page that we can edit. So first thing to do, just as like, what do they call that, where you just do like a smoke test, is just to put something on the screen and make sure that everything is wired up correctly, and then you can start messing around with your 3D scene. So in order to do that, probably should have done this off stream, but we'll do it anyway. We'll do it on stream. It'll be like the whole process from start to finish. Let's get a script going. And in here, we want this to be the full width and height of the screen, so we can do class, or of the window rather. Class is height screen and width screen. But usually your width comes first, so let's put that first. Now we should have a canvas up in here. There it is. Let's install Three.js stuff. Yeah, text. So add 3. And we'll need the types for Three.js. So add -d types. And then, so a lot of this will be stuff from the other project that I've been working on. So I might even go and steal some code from that project, but I'll try to do it from memory. But we're gonna attach here. We'll put an attachment. We'll make a renderer. That's a new web GPU renderer. We'll say you have to have GPU support if you want to use this, and or I mean web GPU support. But I don't know if anybody is going to use this, so it works on my machine, so that's what I'm gonna go with. And that would be like, you know, you just need to change what browser you're using. And I'm not sure what OBS uses as their like browser, I guess. But if that ever is an issue, we can come back and change it to be WebGL renderer. So here, we'll do render.set animation loop. And we just need to save this. So set animation. Can't type animation loop. Spelled animation wrong. This is a promise, so when this component gets cleaned up, after that promise resolves, if somehow we cleaned up a component before this promise resolved, then we'll just do this in a .then callback. We'll just say renderer dot dispose. Okay, now we got a renderer, but we're not rendering anything. So let's call render. We need a scene and we need a camera. New scene. And this is a new perspective. Camera. So if I run this, it should make the screen black, I think. Maybe we have to render something to the scene. Well, let's do like scene.background, new color, red, or let's see, maybe just yellow. Gotta import that. Yeah, so we got our scene up and running. But I don't want yellow. Let's go pick some better colors. And this website here is like a color palette generator, but they've already got plenty of palettes that you can choose from. So this is a pretty decent resource. And I don't know, I don't really have like colors necessarily picked out. But I know I want yellow because yellow is my favorite color. So something with yellow in it. And then, like, what goes good with yellow? I think about like sports teams, and I guess like purple looks good with yellow because of the Lakers. Or you could go like McDonald's, red and yellow or something. But that would look a little strange. So maybe we'll do that. So let's grab this color. This one's not bad. And then to get like the, let me get rid of these. One thing I want to do before I forget is when we start adding these colors in, the tone mapping is going to affect like what these colors render like or like look like on screen. So you can set the tone mapping like this, and by default I think it's no tone mapping, which is set to 0. And then there's like 6 or 7 of these. So if I up this to 1, yeah, you can see whatever 2 is, it's pretty dark. 3, 4. I'm just gonna go with a neutral tone mapping, and I don't know exactly what this does, but I think the colors will come out better. Oh, I gotta import it. But those tone mappings, if you want to like test and play with them, they're on the Three.js website. They've got examples for them, but it's any of these values here. So it looks like there's 7 of them. And you can either like import it like this because it's just a constant, or if you know about it, you could just like put numbers in here and see which one looks best. Let's see, don't need that. So we need to put something in the scene, so let's do that. I'll do a new box This is just so that, you know, we go step by step. Box geometry, let's import that. And then we'll add it into the scene. But our camera's right on top of it, so we need to pull the camera back. And there's the box. We don't have the right dimensions. The aspect ratio of the camera is off, and the renderer size is off. You can kind of tell, but this is like a little bit fuzzy here, and I think that's because it's rendering to the canvas size, and the canvas, without any like CSS applied, has the size of what do you call it? A size of like 300 by 150, and this might be browser specific. So it's rendering. The renderer is rendering to that size, and then it's getting stretched out by the CSS. So that's problem one, and the second problem is the camera ratio, the aspect ratio, is incorrect. So I'm going to steal that logic from the other project for resizing the renderer and calculating the aspect ratio of the camera. So it's all the way over here. And we just need the contents of this. So let's grab it. And here, so it gets the canvas. We don't need to do that because we have a reference to it here. The DPR, that's the device pixel ratio. This is typically 1, but you might have a device that has higher resolution, and it might do like, I don't know, I've never seen a device, but I can imagine like screens that have a lot of like, you know, like a 4K monitor or something like that, or maybe even some phones or something have a different pixel ratio. So that's just getting this and then multiplying it by the client width, which is the width with the like how wide is it when you actually see it in the web page, and then multiplying it by the DPR. That's just a scalar, so if it's a 1 in most cases, this will just be, you know, the client width, and we don't want that to be we want that to be a whole number, so we just floor it in both the width and the height, and you compare it with the where does this width come from? Oh, we compare it with the actual like canvas width and the canvas height, and if they're not the same, then you need to resize the renderer. I don't think you need to resize this. I don't remember, but this will work. So we don't need to do this needs thing. We can just do this. Well, yeah, we do. We can move this into here. And then we'll make sure that this goes like this. Oh, what broke? Oh, yeah, we don't do this. We do it right there. We see it one time, but then it doesn't, but then it like doesn't, it has a bunch of errors. So what's the problem? Our texture size is super big. Okay, one sec. Let me see what went wrong. Oh, I need to set this too. I'm gonna pull in those back in those classes. Okay, there we go. I wonder if this was like I don't know, maybe somewhere there was like a 0 or something. But yeah, we do that. So the render size is being set now. And then the camera, so that's camera, we have a perspective camera, so we could set its aspect, and that's the canvas.client width over the height. Yeah, so that's a box now, or it's a box and it should be the same width and height, and that looks good. But we don't want to show just a box, we want to actually show like text geometry. So Three.js has a helper or like an add-on for this. But this text geometry, it takes a text. So what do we want to show? Let's show like this, and let's see what happens. Probably got an error. Oh, we didn't get no error. I'm kind of surprised. Oh yeah, it does. So yeah, the camera aspect isn't. I guess it's because of this. I don't know, but I'm not worried about that. But it should be updating the stuff here whenever that window size changes. I guess this isn't working because we don't have a font loaded. So the parameters here, one of these is font, and that's like a Three.js font. And we have to load this as well. Well, we don't have to load it. There wasn't anything loading in the beginning, but now we need a font to load. And I guess this doesn't come with any fonts out of the box, because we would see. Well, why do we still see a box? No, we don't. What's the error? Oh. So I guess text geometry just defaults to a box geometry if there's no font. Is that the case? If font is undefined, yeah, it's just an extrude geometry. That's interesting. So extrude geometry, I guess, defaults to a box geometry. Because these are just extruded shapes. So that's why it inherits from extrude geometry here. But let's load in a font, so that'll be font. So we'll need a font loader for this. And in most fonts that you download online come in this TTF format. And Three.js actually has a TTF loader. And like all loaders, it has a load async. Did not get imported? Oh, I need module here. Yeah, so there it is. So the URL, I'm gonna host this font myself, or like, it'll be part of the bundle, I guess. So I did find a font that I liked. You can kind of see some of them in the browser history, but it was called Gloria Hallelujah. And you can get it from Font Source, or you can get it from Google Fonts. I think this is going to be the same no matter. Well, it's going to be like if you download it, it's coming from the same, probably like. I don't know. I don't know how to word it, but they're probably coming from the same location. Whether you get it from Font Source or you get it from Google Fonts. I need better lighting. Yeah, that's a little better. Hopefully it doesn't get too warm in here. Yeah, so to get this font, you just download it. You can either like use it in CSS, or you can download it. So all I just need is just this one. You can add more fonts here if you want to download like a bunch of fonts or something. We'll download it. Put it in downloads, that's fine. And then we need to move it over here. Let me see where we're at. Yeah, so we need to move that downloaded font into the project. And in Svelte projects, you have this assets folder, which is like raw files that you don't want Vite or SvelteKit to modify at build time. And we don't really want it to touch this TTF file, so this is where I'm going to put it. So if we go here, and then we go to source lib assets, I think it is, we can move that downloaded file into here. Oh, is there already? Let's see. Yeah, we'll move it in here. It's a zip, so we'll unzip it. Pretty easy to do, but let's move it in here and then we'll open it. And it'll open here, but that's okay. We can just get rid of this. And it should be there. It's under that folder. So I don't know how to get the path of this thing, but we need to go into that folder. We need to get the absolute path of it. Not like from like the home directory or anything, but from the root of the project. So I guess this OFL file is like the licenses and stuff. Yeah, this font can be licensed under this, and it's an open font license, and it's just a copy of that license, I guess. So you should include that with your project. Like if you were to, what we're going to do is put this on GitHub, so you should leave it like it is. That way, you know, the license is with the font, or with the file. Is it current work? Oh, it's PWD, isn't it? Yeah, that's an easy enough name to remember. So here, if you look again, we got the asset. Oh, look at all these. It's this, so let's grab that. And then it's $lib slash, oh no, let's do this, assets. So Svelte has this assets function, which if you were hosting this and you had a different domain, assets would account for that. It knows the, well, let's look it up, because it'll explain it better than I can. Kit. Yeah, it resolves the URL of an asset in the static folder. Prefixes it with the assets. So if your project was hosted somewhere and had a different base path, then it would account for that. So assets, and we have it under, it's, you know, it says here that whatever's in the static folder, so that's good. And I think the folder name was the same as this file name. Let me check. Oh, where's our static? Oh, I put it in the wrong spot. Well, this needs to go here. And then this is wrong, I can tell. Something like that. Oh, asset, not assets. Okay, so whenever this goes from, like right here where the H is, sometimes on the same line, this is an LSP thing, but you'll have both, in this case it's a hint, like it's telling you this isn't a big deal, it's not going to break your app, but the URL is unused. Now if it was an error, like this, errors I have it set to their higher priority, and now in this case you can still get the hint, because there's two diagnostic like errors on this line, but if you go in deeper into the line you'll actually see the error. And I have it so that the purple color is just like warnings, and then the actual red color is like things that will probably break. Oh, I can tell this is now over. So let's go here. Get rid of that. Let's see if this... That last soundtrack was pretty good. It was kind of short, but it's pretty good. So this returns a promise, this load async thingy. So we'll need to either await it, which you can do in Svelte components, or we'll just do everything in the .then callback. So after we have loaded the font, we get the font out, and this should be it's typed as font data, which is what the font here is supposed to be. Even though they don't have the same name, but that's okay. So we'll call this geometry. Oh, I might need to turn it into a font. How did I do that again? Oh, okay, yeah. So there's one step in between. So that kind of tells you, and this I'm glad I figured this one out, is this is font data, but this one's an actual font. So they are different, and that's good, because I was kind of worried that they weren't different. It would have been weird if they weren't different. But now you can create a font from this font data. And this will just be data, I guess. Yeah, that looks better. So let's apply it to the mesh, and then we'll add the mesh to the scene like we do here. And now let's see what we get. Oh, I think the app crashed somewhere. Yeah. So it doesn't like this URL. Let's take a look at it. And so that it doesn't keep crashing, I'm gonna put a catch here. Well, let's put this in its own variable. This is the promise here. So if that promise fails, just so that the app doesn't keep crashing, we'll catch it and we'll just log it. And then we'll do that like that. Okay, so let's run the app again. Now, when it fails, it should log it instead of crashing. No, it still crashes. What's the problem now? I was pretty sure that was gonna work. But this is the path. Is that correct? Let's take a look. And I don't think you have to do dot. Yeah, it's just like this. TTF. This is a different kind of soundtrack than the last one. Let's skip ahead. Alright, I gotta figure out why it isn't loading this font, because it looks correct. Let me look at the notes, like I always do. Let's see. Failed to parse URL from yada yada yada. Why? It should be a relative path. Oh, I think it's the dot, maybe? I don't have a dot, though. I should just know where to find this. Okay, so that's good. We're not crashing. Invalid URL. That's not good. Okay, let me see my downloads. Do I have? No, I don't. Okay, I guess in the original, not original, I should say, when I was testing this stuff, I guess I did use the font source, so let's try that. And then I could just copy and paste over that part of the project, just to get it moving. Let's download this. That's fine, I don't know. Here, downloads, here. What was this? This was static, right? Okay, let's move that downloaded folder here. And then I kind of want to move it into fonts, like a font folder, tell you what it is. But just looking at that file name, you kind of don't know what it is. Unless you know what that font is, I guess. So let's make a directory for fonts. And we'll move this into fonts. Okay. And then here, I can just copy what I have in my notes. Okay, no error, that's a good sign. But this, I'm like, why isn't anything showing up? Is because the font is, or like the geometry is very big. And you might be able to see that if I pull the camera back by a lot. There's the font, or the geometry at least. So two things, it's very big and it's not centered. And we kind of want it centered because, well, I guess what we can do is scale this down so that it's an easier size to work with. But when we scale it, we need it to scale around its center. So you can actually, before you like turn it into a mesh, you can mess around with the geometry of the object, and you do that. You know, this returns a buffer geometry. Well, text geometry is a buffer geometry, but you can do things like translate it, you can center it, that's the one we'll do, and you can scale it, I think. But this is something that happens to the buffer attribute itself, to that like raw data. So this is not something you would want to do in a loop, because modifying the vertex information, like every frame, if you were to do it in this like render loop down here, is something that you want to avoid doing. Normally you would like set a like the initial size of the geometry. You know, you'd modify its vertices, and then what you would do is convert it into a mesh, and then you would translate the mesh and the scale and all this. And what was the last one? Like if you need to rotate it, for example. And that is probably like a uniform that's sent into the vertex shader, and then or it's probably a matrix that's sent into the vertex shader as a uniform. Like the scale of the object, and you know, have you ever heard of like RST? That's the rotation, the scale, and the transformation of the mesh. So doing that per frame is a lot faster than modifying vertex information per frame. But here we just want to do it on the vertex level, or like the geometry level. Then because we haven't made a mesh out of it yet, and there's no loop happening here, so we want to like load up the geometry, scale it down, and then we can use it as a mesh. So if we do that, it will load a little bit slower because it has to, for one, load the TTF, turn it into a font. You know, it has to load it, has to parse it, has to turn it into a font, has to create a geometry out of it, and it has to center the vertices around like the center of the geometry. But now it is centered, and but it's not scaled. So when we start working with camera stuff, like this isn't a very easy unit to think about. 900 units, I just kind of got lucky that this looks like it's centered pretty well. But I'd like something like, if you were to put in text here that is like very long, you know, it's gonna be off the screen. And I just remembered, like, we should get this information from the URL parameter. So to do that, you can get access to or what is it? Page dot. It's not $page. I think it's page dot. Let me look at this felt docs. So in kit, down here you have app, you have, I think I have app page somewhere. Maybe it's state. Yeah, okay, here it is. So we need this. And one of the properties on this guy is the URL information. So it looks like that comes from this import. And then we take the page and it has params, or has search params. Let's see, URL dot search params. Yeah, here we go. And then this is kind of like a map. But you can call .get. And let's call this text. And this may return null, in which case like there was no param for that. There was nothing set for that search param. So if that's the case, then we'll just return something like this. So that'll be our text. Oops. So we should see a frowny face now. There it is. But now if I go up here and we do question mark, not, what is it? You can either put a space here or you can do it like URL encoding. And that. But that didn't work. So what happened? Oh, I didn't set text. It needs to be text equals. Like that. So now I can just point the OBS browser source to a URL like this. It won't be localhost, it'll be wherever it's deployed to, wherever it's hosted at, that domain. But now like anybody can go in here and all they have to do is just update the text. Like that. But what we need to do, back to like centering this font geometry, or its text geometry. We have it centered here. Now we need to scale it down. So an easy way to get it to be like a normalized, like fit within a 1x1x1 box, is to find the maximum dimension of the bounding box and then scale the mesh by that bounding box. So what that will do is you found the maximum. It's either going to be the height, it's either going to be the width, the height, or the depth. When you divide out the maximum, one of those will be equal to 1. That will be your maximum dimension. And the others, because they're not the maximum, you know that they're going to fit, they're going to be something in between 0 and 1. So that will fit it into a 1x1x1 box. And in our case, it will probably be the width. That will be the maximum. But I guess it would depend on the font, and it would depend on the text. So you take your text, or you take your mesh. Let's call this text mesh. Take your text mesh, and you, well, you need a box first. So let's call a box, new box 3. And we could set it from that mesh. Oh, I need to import it. I always forget that. I need to import it. Set from object. Let's pass in the mesh because that's an object. Now this box has the dimensions of the text mesh. Down here. So you can kind of get an idea of how big this thing is. In the X, you know, it's almost 900 units. In the Y, it's like 100 units. Or maybe like 120 or something, 110. But you need to get, or we need to get the maximum dimension of that. So you can take the size and you take the box.getSize. That will put that into a target vector. So let's call that. We might want to save it. So let's create a new vector. And put that in there. Where do I define size? Oh, right here. Duh. And then we need to get the max. So that's max dot or math.max, and we can just spread size. So these vector 3s are spreadable. And I won't go into how you do that. It's pretty simple, but it's just got a symbol for like the actual class has a symbol property or whatever for spreading. So that will spread its X, Y, and Z component, and now you have the maximum stored here. So you just take the mesh and you set its scale. Or you take its scale and you divide out the max. But this needs to be div scalar. It might even need to be divide scalar. I can't remember. Oh, I always forget this text mesh. So if you do that, our mesh will be really small here. The camera's pulled back too far. But like there it is. But this box here, if we were to visualize the box, we need to recalculate the box now. Set from object text mesh, and now we can visualize that box with a helper, and we pass it in the box, and then just add it to the scene. Let me take off the background for a second, or let's put it to black. So, oops. This, like, it's really hard to see it, but this yellow box, the width here is a unit of 1. And then, I don't know, there's some box or something that this will be guaranteed to fit into. Here's kind of like normalized the size of this thing. But now we can move the camera in such a way that it will focus or like fit the box to the camera, or fit the camera to the box. And you don't have to do this like scaling in order to do that, but I do want to add a shadow to this scene, and just making it like a normalized units or whatever will be easier to think about. How do we add the shadow? But we'll do that next. So let's put the color back. We don't need to visualize this. But I do want to position the camera so that it's shows like the entire text. So let's see if I remember how to do the math of this. We have the maximum. We need to take, so the idea behind this is that you have your like screen, and you want to put text in such a way that it fills up, the screen. The camera has some field of view like this. This is the camera. There's a better picture of this on the Three.js website, but you need to fit half of this screen, like size or whatever, to fit within half of this field of view. So let me just find that image. It's in the article about loading models. So this is it here. Oh, dang it. I went back. I need to go. Where is it? Where is it? Right here. So the math here, like you can figure out the math. They tell you how to do that here. But the distance is this. And that's where we need to put the camera or move it backward in such a way that, you know, we can see all of the object. In their case, they're loading a windmill model, but ours will actually be that text. So let me leave this up for now. But what we're going to do is calculate the center of the text. And that will tell us, like, from the center, how far back do we need to move. That's this distance here. So the first thing to do is to get the center. So the center should be 0, 0, 0, but you know, just in case it's not, we can actually just calculate the center. And you know, it might be best to recalculate the box. So we adjusted the scale here, but we did not adjust the box. So the box is still using the old values, like pre-scaling. So we'll call set from object again. And you can tell like this and this here are kind of doing the same thing, so you might put that in a function, but I'm not going to do that at the moment. But that will recalculate the box's like dimensions and stuff, and then we can save the center. We'll do box.get center. Then we need to, actually we can just put the camera there, so we can, this takes a target. We'll say modify the camera's position. And now we need to do camera.translate. Now we need to pull the camera back by some distance, but we don't know what that distance is, and that's what we need to calculate. So it's 1/2 of the maximum size. Divided by, it's this little function here. Divided by the tangent of 1/2 of the camera's viewpoint. But these field of view is in degrees, so we need to calculate, we need to transform it into, or convert it to radians. So this comes from MathUtils, which is part of Three.js, and then it's 1/2 of that. Okay, let's take a look at the distance, make sure this is calculated correctly. It's still getting the really big distance, so... Oh, that's because the max here is set from this old size. So we need to recalculate the size. That's easy. We'll just do box.get size and put it back into size. And then need to get the max of that, so max is math.max, which means this needs to be a let. Oh, we need to spread this. There we go. So now it is, doesn't depend on, like if we put just A here, it will like maximize, you know, and you probably want to put some scalar out here that adds like a buffer to each side. I gotta sneeze. Maybe not. Okay. I thought I had to sneeze, but I'm good. So what was the text? Text is this, so that's not too big of a buffer. See, I don't know. Maybe we can put this as a parameter as well. See, like, where do you want this mesh to be located? Or like, do you want it to be really small in the screen, or do you want it to be big? But then I have to worry about like parsing the number here, which isn't too big of a deal. Let's do like scale. Or if we can't find it, we'll default to 1. This will be a string, but we need to convert that into a number. So I'm not sure what will happen if they don't pass in something that can be converted. Like if we do plus of hello, yeah, not a number. So that could be something that we account for. Maybe we'll do const scale as number equals plus scale. This could be not a number. So in order to check for that, if is nan, and just do scale as number equals 1. There might be a better way to do this, but this is what I just thought of now, so I'm gonna run with that. When you do plus like this, I guess it's guaranteed to return a number, and if you do like type of nan, it is a number, which is really weird. That's some JavaScript weirdness for you. So I guess this is guaranteed to return a number, or nan, which is really a number, and then we're just checking for that here. And then we take that and then we put it down here. So if we do, how do you do more than one? How do you separate these? Isn't it like this? Oh, and then we probably want to do like 1 over that. So this would be like, you know, if I had something really long, well, you could tell if I didn't pass it in, like there's still some room here on the sides. What if I want it to be a little bit closer to the sides? Well, I could come in here and I could say scale equals like 0. Or let's do 1.1. It's a little bit bigger now. Yeah, that takes care of that. Let's put a better material on this thing. I'm gonna use, so I kind of want to mess around with like shader stuff next stream, if I can do some research and get it done on time. So I don't know, Toon Material might work for now, but I'm just going to use a really simple shader for now. Actually, let's use Lambert. Lambert material. And do I still have that color palette? Yeah, so I think we picked this one. Let's bring in something darker. Grab this. Put it on the mesh. Now it might be unlit. Yeah, we don't see that color, but that's because there's no light in the scene. Like if we make this a mesh basic material. We're getting that color, but this looks black because I think Lambert is a lit material, so you need some light in the scene. And I want a shadow. So what I'm going to do is fake the shadow with a shadow mesh. But we still need light in the scene so that this thing is lit properly, so that it's colored properly. So we added, let's call this, so this doesn't, like the lighting doesn't depend on the mesh, on the font being loaded and the text geometry being in the scene or anything like that. So I can set this to a variable like add mesh, and then down here, it probably would be best to clean up this stuff if this component is unmounted. So it's just a good habit to get into, to clean up your GPU stuff. So here I want to return a function that does the cleanup. And the things that we need to dispose of is the material and the geometry. And we need to remove it from the scene, so scene.remove text mesh. The text mesh will be the only thing using this material in this geometry, so there's no point in like keeping it around. You know, if you had more than one mesh using this material, you probably wouldn't dispose of it this way. You'd probably keep some reference counter or something, and then once that reference counter reaches 0, then you can dispose of it. But it's nice that this text or whatever is the only one using this material, so we can just dispose of it like that. But what we need to do down here is once we add the mesh, that will return the cleanup. And we can even call this remove mesh, and we just call that. I guess it could be void because of this. Yeah. So we can do this. And probably better yet, we should do this instead. Well, I don't want to catch it down here. I want to catch it up here. Which in that case, you know, if we reach this block, we didn't do any of this. Because this will wait here until this, right, this is how promises work. This is ready. But down here, we didn't go do through any of this, so there's nothing to return. But I guess this catch here, let me do a little test here. If we return hello, is this typed as string? Yeah. Okay, that's good. This is a like a union of the dot then and the dot catch. So it could be nothing, or it could be that function, that cleanup function. But this will only run, you know, once this thing here has either caught or has either thrown, like caught the error or it has moved on with the next promise in the chain or whatever you call it. Yeah, so that's cleaning up the resources. That's a good habit to get into. But now we need to add light to the scene. So let's make a directional light, and that will be what we use to create the shadow. And that'll probably be the only light in the scene at the moment, so I'm just going to call it light. And by that logic, this could just be called mesh. Yeah, so that's a new directional light. Its target is always set up to be 000. I believe. But this light thing has a target from its position to the target's position. And this is like, yeah, you can track different objects. So you can pass in, yeah, you pass in an object here. So we can just pass in the mesh. Means we want to create this thing before we jump into this, like before we create this promise. And then we'll get, can we get the target? Let's call light.target. And we'll do light.target equals the mesh. And on cleanup, we'll restore that. But we need to add the light to the scene. So let's move this down here. Yeah, now where do we put the light? Because right now it's at the origin, so we need to translate the light. And then to do that, we can just move it like a really far distance away. Will probably work, but we probably want it to be based on the size of this thing. So we have the max right here after rescaling, like after normalizing the scale and all that. Let's make an axis. So we're gonna move this thing along an axis. The thing being the directional light. So new vector 3. And I want it to just be like 1 on 1. We'll normalize that. And then we'll take the light and we'll translate on axis. Now how much do we translate? Let's do max. You can kind of see the colors now. Let's put a color that's a little bit easier to see for a second. Yeah, there's the colors. If we take off the tone mapping, might be even easier to see. But it's no longer black, now that text geometry is lit. Let's get this back. And then just to be sure that the light is like correctly positioned, I think you have to do something with the target here too. Like you have to inform. Oh yeah, you have to inform the helpers. So if we make a directional light helper, We add that to the scene, but we need the light. Yeah, it's like this little white line. I don't know if you can see it, but it's kind of like right there. If we pull the camera back even more, like you can see it there. It's pretty big. That's because our text is really small. Maybe not so far back. But let's see, this is the X, so we don't want to, this would be like, we moved it over here a little bit. I kind of like where it is in that regard. And the Y, I kind of want to move it down a little bit. Z is probably good. That's weird. Oh, yeah, there we go. Let me do this so see the text more clearly. And it is looking at the center here, which is good. But I'm thinking that's 000 anyway. What happens if we don't set the target? I'm just looking at how my notes are different. So in the notes, I have this as 1, 0.25. But I mean, these numbers we can play around with, and once we see the shadow, it'll be easier to know, like, where do we want to put this light. So that's probably what we should do next, is add the shadow. I'll make sure that this thing is translated by the right amount. What is it called? Light. But I think if this thing is always in front of, like the Z is always more than the size of this thing, it doesn't matter where it's translated as long as it's in front of the font or the text. So the text, the maximum like Z. I mean, we could just do max here as long as like it is. As long as, how do I put this? As long as the Z is not the maximum. Oh, I gotta think about this. I mean, the easy way that will be guaranteed to work is just to translate by the maximum here. By the maximum, like, dimension. That should work. Let's add the shadow mesh. So that's shadow. I'll do it here, and if we can move it out of this, I'll move it out of the dot then. All back. But this is the shadow mesh. And this comes from add-ons. It needs a mesh, so that will be our mesh. And we have the shadow here. And then this shadow thing has an update property, or sorry, an update function or method. And you can see there it takes a plane and it takes a light position 4D. So the plane we can import, and then this takes a normal, so I wanted it to be the like ZX plane. So the normal that comes off the ZX plane, you know, here is this is your Z, and this is your X, and this is your Y. So in the ZX plane, the normal that comes off that plane is just has a Y component. So this little vector here, if it's normalized, it'll be 0, 1, 0. So that's 0, 1, 0. And then the second parameter here is the constant. That's a like, this plane is pointing in that direction, but how far do you want to translate it on that axis? So we don't want to translate it at all. And is that, yeah, that's not required. But we need to do this update in the loop. So the loop is not ready until the renderer is ready. So the kind of tricky part is how do you get this update thingy? Like if we just do it once, let's just do it once and then we'll figure out how to move it into the animation loop, because this geometry eventually we're going to have it like moving around and we want the shadow to follow along. So it's not moving at all right now. So this should work if the thing is static. This thing is the second argument here is the light position. It's a 4D vector. And it's the actual position of the light. And the second parameter, or the fourth parameter here is like the W. What is the W? But I haven't figured out how to control this thing to get different results. So I'm just going to set it to 1. And we pass that in as the second argument. And then we need to add that shadow to the scene. Okay, we don't see it. And I think that's because our camera it's either because the mesh needs to be raised a little bit, or the camera is like right in line with that plane. You know, looking at it head on. So let's move the mesh. So right now it's like located right here. I want to move it off of that plane that sits right here. So after we do the scaling, we can just translate the mesh itself. And that's in the Y direction. So we'll translate Y. And we'll come up. So this is 0, 0, 0 right here. We just need to do half of whatever this size is in this Y dimension. So that will bring it upward. And I am really not sure about this light targeting. Yeah, let's pull the camera back, because I don't see my light or my helper at all anymore. Where did we do the light? Yeah, well, that's weird. I don't see it at all anymore now. Oh, look at that. How does it know that this is... Okay, I'm just going crazy. Let's create the light here. I mean, are we still seeing color coming through? Yeah. Something's wrong, I think. Because I should see the light. It should be in front of us. Or like, you know, a little line that comes kind of like this. Okay, let's do this. After we translate, okay, do this. So after we do the scaling, which happens here, then we recalculate the box. So now the box, take a look at the box here, or let's take a look at the center. Should be like up 1. Oh, okay, I see. I think I see the problem now. We need to recalculate the box. You know, that's fine. That's fine. Why is that 55? Oh, yeah. I need to do it down here. Okay, there we go. Nice. So now our mesh is up a little bit. Like off of that 0 or that, let's see, it's 0, it's 101 plane. Or not plane, but you know what I mean. There's a plane right here. We can't see it. And I guess it's here now. But we don't see the shadow. Let's figure that one out. need to add the light to the scene, that's right. Okay, so light's in the scene. And did we translate it? Yeah, we did. I was having trouble with this earlier too. But let me do this so that I know it's not like because something's not ready at this point. But the way that I solved how to do this, because we want this mesh to animate, I made an animate mesh, or like a, what did I call it? I guess animate mesh is more correct. I just had like a variable outside of this function that I set once, you know, the mesh was ready. So up top here, we'll do animate mesh. And that's either going to be null or a function. Time is a number here. I don't want it to return anything. And we'll set it to null. So we get the time out here. We're not using the time yet, but now in this function we can call shadow.update. And it'll take plane. And it'll take light position. Now in the main loop down here, we can check for that. You do if animate. We can actually do it like this: animate mesh, and then just call it with the time. So to make sure that that's running, let's log something. And yeah, that looks good. So now if we move the mesh around, it should be updating the shadow. And I gotta figure out why we can't see the shadow. I'm just looking at. Yeah, stream has gone quiet. What's wrong? I'm just looking at the. Oh, I want to do this too. After this, the cleanup part of this is we need to set the animate mesh back to null. That's an important thing to do because after we dispose of them, they won't be available anymore, and then there's nothing for this update function to reference because it has a reference to the mesh. Can you dispose of the shadow too? It's not. So if we figure this out, then we'll just need to animate the mesh and that'll be it for now. And then next stream will probably be tweaking all these things, making it look better. I don't see where things went wrong. Okay, that's right. Let's call this 4D. Well, we don't need it. I mean, yeah, we'll call it 4D. Why not? Let's see. I guess we can animate the mesh real quick. Just so that, you know, do something else and then come back to the shadow thing. So meshes have a rotation property. This is where we'll need the time. So this is the X, Y, and Z. This is an Euler thing. So I want it to kind of like shake like this a little bit. So it will be rotating a little bit in every direction, in every axis. But if you want something that like oscillates like that, the sine function oscillates, and we can pass in time here. But if we just pass in time here, it will be oscillating way too much. And to kind of show that, you know, it's like flipping out. But you can scale back the time here. So you kind of like scale it down so that every time that the time increases, and this is just an accumulated value. Every time that it increases, we're scaling it way down. So if you do that, you can see now that it's a lot more like friendly. It's not rotating very fast, it's rotating very slowly. And this ranges, so the sine's output ranges from -1 to +1. So you can see like it doesn't do a full rotation, because full rotation would be like 2 pi. So it's going, like, the rotation is going from -1 to +1. But if we add another thing here, let's take sine of time over, I don't know, like 250 here. We get a little bit more movement. And let's probably do the same thing in the Y. I don't know, let's do like 200 here. So now it's rotating in every axis, but if you want to scale, like you don't want it to rotate so much, that's what this amplitude, like this thing here outside, you multiply it by some number outside. And you can scale this down by a lot. So if we do like something like these numbers, and this is just like a matter of finding numbers that look decent. So in my little practice, I actually use decimals, which I normally don't do. But the numbers that I found that I liked were these. And then it was 300, 200, and 350. So that kind of looks like that Petscop. Well, the Petscop one was just going like this. I don't think it had any of this, or any of this. So the final thing we need to figure out is why don't we see the shadow? Where do we do the camera translation? Right here. Let's translate on the Y by a little amount, and then after we do that we need to look at the scene. So that's going to be the mesh position. Yeah, okay, so our shadow is there. Oh, I know why. Well, one of the reasons that we see something weird is that shadow mesh uses the stencil buffer. So you can kind of see here, like the shadow is a overriding itself like twice. But if you set the stencil buffer to true, you get rid of that. So it must be because we're right in line with that plane. And how do I fix that in my notes? Plane is here. Well, let's see. What I'm tempted to do is just copy this and paste it in, because the only difference between what I did on stream and the notes is that part about the scaling, and that's pretty small. I can just add that in again. So let's try that. Now the scale here is a parameter that we get out. Oh man, look at this. Look how it... Well, I didn't squish this. I can't believe I was programming like this. Oh, I guess I did get rid of all my... This looks so weird to see just a massive block of text like that. Oh, I just looked back at the chat now. Yeah, we're almost done. I need to add in a way to scale this thing from a parameter at the top here. And then I'll put it in the, I guess the final thing to do is just make a scene out of it in OBS. I'll do that live. But the scale here is hard-coded right here, so I need to get scale out here, and scale will say is a page dot URL dot search params, and we need to get the scale. If that's not set, we'll just default 1. Then we need to turn it into a number, so scale as number, and that's that operator there, but that could return nan, so we need to check for that. If it is nan, then we'll say scale equals 1. This has to be let because we're reassigning it. And scale as number. Oh yeah, scale is number and scale is number. Okay, so if we put in like 3 here. Oh yeah, it needs to be 1 over that. So where is it? What is this song? I think it changed to a... No, it's the same. We're almost done, so let me... I liked that first soundtrack. That was pretty good. I'm gonna put that one back on. Scale, what was it? We just set it to 1. Let's do 0.7. I mean, that shadow is not so great. I don't know. Does it look better at a larger size? Maybe not. But I might want to tilt the camera up a little bit, so like rotate it around that. Because right now it's just being pulled back, but we might want to move it up just a little bit to get there. We can move that shadow plane actually. That might be make more sense. So that plane is just sitting at the XZ, like it's a plane on the X. It is the XZ plane. That's what I'm trying to say. It's playing the offset. Let's do like -1 maybe. Maybe that's too much. 0.1. Yeah, so it's up there. We want to do maybe like 0.1. That might look a little bit better. And like all of these things could be something that, you know, could be either be read as search params or you know, controls or something up here. But I kind of like keeping it as search params. Because if I had to put like controls up here at the top, I would have to worry about how do you like hide the how do you hide those controls? And I don't want to deal with that at the moment. Yeah, I mean something like that looks pretty good, I think. And now if we put in like you know, this here. But how long? 2 hours? What time is it? Oh, okay. Let's see, what's this? I made you one too? Oh. How'd you do this so fast? Oh, well, you made a marquee. I was like, what the heck? That was pretty good. Maybe I'll use that. Yeah, I've even got the smiling, or like you have the cool emojis and stuff. They say not to use a marquee, but I think it looks great. So this is good enough for now. Do you like it? I like it. The idea of, yeah, I think like valid CSS IDs are just like any alpha, or what is it, like Unicode or something, right? So you can't see that in your unless your terminal supports it. But I've seen people use those in like VS Code and stuff. And I think you can even maybe not. I was thinking like yeah, yeah. Yeah, in other systems that accept Unicode and stuff and have a way to display the Unicode character, it's always something funny you can do. Like imagine if some of your like database tables or something, you could use Unicode characters. Or like, you know, rows in your data and stuff like that. I need to deploy this. So I need to make a check last thing that this is ready to go. I think we do need to dispose of this light. And when we add it to the scene here, we need to... Actually, we need to remove all these. So we'll take this, put it here, and then we can just call remove. Oh, I didn't mean to... I meant to copy it. Yeah, so that's removing them. I think that's all the cleanup that I need to do. I don't like how it squished all this together, but I'm not gonna do that on stream. I'll do that off stream. Is this ready? I think so. So let's make a repo out of this. Dang it. Too fast. Get init. Oh. Using master, this default branch name will change to main. Okay, why do I have a VS Code dot file? Okay, we're gonna ignore. And what's this? What's in here? Oh, I'm so used to looking at that Astro project. I don't even know what SvelteKit comes with anymore. But let's make sure this builds and preview it. So if we go here, so build properly, let's see if it, okay, we got an error. Why did you error? Why did you error on me? Oops. CDN? Oh, maybe so. Well, no, this asset's locally it's downloaded and just shoved into the assets folder. Or the static folder. TTF parser? Yeah, right here. Oh, do you need... Well, I got a TTF loader right here. And your bundler. Do you really? I don't think so. I don't think so. But it couldn't load the URL is what it said. And it didn't even like catch the error either. What's the problem there? This is hard to look at. Don't ever write code like this. Is the file in the build? Let's check. Where's the build? Oh yeah, it's in dot. Is it in dot build or what do I call this? I don't see the build. Maybe dot SvelteKit? Is that where they put builds now? Maybe output? This is like all client side. Yeah, here's the font, so it's there. Oh, I don't know. But the font here... Well, maybe it's not putting... I don't know, it should. There's some eval usage here in Three.js. Somebody's gotta go in there and fix it. Static assets? Yeah, so this should just be... And that's what that asset helper function here is doing. This should resolve it to the correct path. But if we do, let me just log this, so we'll build this and see what this URL actually is in the build. No, now it won't even build. Oh yeah, PNPM is a lot faster. I can't, like, I was surprised when I saw somebody, because I used to use NPM a long time ago, and now whenever I see people use it, it is so slow. Maybe I need to configure the so in like SvelteKit, you have to configure these what do you call it, adapters, and I think there's one for GitHub Pages, which is where we're gonna send it, but I don't think I need to do that quite yet. What's the error here? Oh, I'm in the wrong folder. Uh, 4173. Okay, fonts. Blah blah blah. So that's the URL here. This is always annoying when you have to deal with these things. Like, it works really good in the Astro project. But it doesn't like that path. And then I wonder... Let's look at assets. Like, how do you use assets? I just want the Svelte website. Come on. Asset. Where was that at? Isn't there one? Yeah, so assets goes in build, that's correct. It's here. Client. Oh, look at that! Look at all the stuff that's here. But where is the entry point? I guess it's an entry. Oh, where's the actual like HTML file that's loaded? How do you find files? Find. I don't know how to use that command. Yeah, but it's finding, or it should be here. Dot fonts. No, it's probably something really, really simple. But that's usually the case. Oh. Well, I don't want to troubleshoot it on stream because that's boring content. I try to. Yeah, that's how you would do it in a CSS file, right? But I'll just show it. Like, this will work. It do I still have the this thing? Yeah. So the development app is still running. But if we go over here, you guys can probably still hear me. This is the current web font loader. But I think that you can just do it in Three.js. They have all that stuff built into the font, to the TTF loader and stuff. But I have to take a look. Because the examples on the site, on the Three.js site, like this one, they just load their font. Oh, why does it take so long to load? That's a GitHub problem. I just load it from like a relative font. Well, maybe it's that dot that's getting added. Because if you just load from slash, that will be a... so just to make sure this is the case, if we don't use that asset thing, now let's try it. No. Oh wait, I'm in the wrong directory. I guess this. Oh, I still didn't like it. Node internal, what's that? Oh wait, never mind, not that. Did not, oh, I guess I got rid of the console.log, huh? ttfloader.parse. Parses the given and returns JSON for creating a font. So that might be used. I don't know. But loaders have a parse, so it is an override. So I'm assuming when this font thing is being created right here, it's calling whatever this is. But it's part of the loader, so this isn't even, this is like font data. I don't know, I'd have to look at the, source code to be sure. But I will figure that out sometime tomorrow. Oh, you guys can't see. Sorry. How long was that on for? Dang it. Oh well. At least you were able to hear me. But let's run the dev thing again. And I'm gonna restore that back to assets. Yeah, a little bit of stream scuff is not a bad thing. Okay, so if I go over here and if I add a new browser source. Oh yeah, just use whatever like fonts come with the system. Oh, not a local file, we want a URL, so we'll point this at localhost. Is it 5173? That would be cool to make. Because right now I think what they do is they read in the TTF as like, you know, if you ever worked with fonts, they have like contours and all this, and the actual font file is like, how do you draw all these contours? And I think they take a look at that and then they create the Three.js shapes and then they just extrude it. But doing like an SDF text renderer would be pretty sweet. Well, that looks good. I mean, is it using an SDF? Simplical. Oh, you got vertices and faces. Vectorized text. What's that? Oh, that's from a import. Parses the font. Oh, okay. Creates the vertices. Yeah, it creates vectors out of them. I guess that's what they mean by vectorize. I want want to edit this, please. Let's do. Oh, now I can't even load that font. What the heck? Something's like way broken. Well, at least the scene is working. I'm going to call it here. Everything's breaking, so it's time for a break. Myself. Get it? Do you get it? Yeah, you got it. That's okay. I think next stream will be Thursday, probably. So I will fix everything that's broken off stream, and I will upload this. I will, push this up to GitHub. We'll make a repo for it and all that. And then when next stream starts, we should see a new starting soon screen. Oh, you're welcome. Thanks for always stopping by and supporting the channel, I guess. So Thursday, that's the plan. In between there, I will do some research about how to get a scene that looks like those influences that I showed in the beginning of the stream. I'm sure there's information out there somewhere, or we can steal like a shader toy example or something and convert it into TSL or something. Yeah. That's it. So everybody have a good day and make it through the work week, and I'll see you guys probably Thursday. I don't have a way to do like Twitch stories because I'm not, an affiliate or anything like that. But if I do stream, it will probably be around lunchtime. So be on the lookout. Yeah. It's just always like, what do you say at the end of the stream? You just say bye, right? So bye everybody. See you later.